是讲那个是讲跟这个 graph 上下面怎么去我要很虚还是静是虚还是
错了，我写错了，是比加，这个是比加。加的话就是拿回去，同样之前我 derive 的咯，变成 negative 咯。你讲啊 ？Okay, now for the second half of the lesson, we start look at curvilinear motion. Curvilinear motion. Okay, we start with this diagram. So let's say you have particles moving in a pathway that looks like a curvature motion. So you have an initial O, and you follow the blue line, and you start with a position which is S, and every time you stay with the curve, right, with the curve, with the dot, and it's a curvilinear motion that asks you to in the tangent and cylindrical position. So what does it mean? Is that you know that previously in a previous section, we have a tangent direction of velocity. So now what you do, you can break your velocity, velocity in tangent direction and another direction, another axis called normal direction. Normal always pointing to the center of the curve. So basically you just use your ruler to draw these two axes, tangent T and normal N pointing to the center of the curve, right? And we start to label the direction for T, direction for N. Means if in the vector form, we'll use UT and UN. Tangent and that one. So the rest you read. What is important now is that we will further look into curvilinear motion, where now we add more precise axis for the curvilinear motion, which previously we only look at, V is always tangent, and then acceleration is pointing inside. Now we look deeper into curvilinear motion, we give them an axis with its tangent and normal direction. Just now, the previous example, we look at X and Y direction. Okay, just now, the projectile one, we look into X and Y direction. But what happens if you have a curvilinear motion which is so complex? It's better you change your motion. You look in terms of tangent and normal axis for that particular particles, for that particular curve. Previous projectile, we look at the overall picture, start and end. So this question, when we break into tangent and normal, we look at that particular curve. We look at that particular curve. So don't confuse with the projectile question and the one that we're going to discuss now. We look at that particular curve motion. Okay. Now, for example, I'll give you another. Let's say this particle move and then it turn this way. What is the tangent motion, tangent and normal axis for this particle at second half? This is tangent axis. This is a normal axis. This is the center of this curve. And the relationship between tangent and normal, they are 90 degrees. So basically just use your ruler, put there, pointing to the center of the curve. You draw the axis, then you will get UT and UN. This is just a vector direction. This UT, UN here is like the IJK. It's like the IJK things in the X and Y direction vector here. Okay. Yeah. So this is just to introduce you that actually you can zoom into that particular curve and do analysis for that particles. Okay. So now we call it planar motion, means we assume that it do not move up from the screen. We only look at that planar motion, this plane motion, this whiteboard surface. It do not move up from the surface. So when we cut the things and we assume that it's moved along the whiteboard, then we can use this analysis, right? And it's positive when it's increasing, means if following the path. So if going this way, you'll get a positive tangent direction, means the direction of the particles. This one always follow the direction of the particles. Direction of particles. Huh? And this is a unique vector. Like again, what you see, UT, UN, they are the I, J, and K. They are I, J, and K equivalent. I, J, and K only in X, Y, Z axis. But when it comes to this curvilinear motion, then you use UN and UT for curve motion. Okay. All right. Now another one is that when you study about curve motion, and you need to use normal and tangent, you need to recall something that you learn in your circumference or a section of a circle kind of mathematics chapter. You have a theta, r, radius, and your s, which is your circumference of your small section of the curve. This is in radian and not theta, not degree. So ln s equal to r theta. You learn about this equation in one of your mathematics chapter, right? So this is what about, this is the s equal to r about. So I just want you to tell you that on the curve, you have a r here. However, to differentiate from other section of the chapter, we do not, we try to avoid using r, but when you talk about curvilinear subject or curvilinear path, we will replace the r with rho. Means every time you use rho, you know that, oh, now I'm solving curvilinear motion. I'm doing curvilinear motion equation. And rho always link with the normal and tangent direction. Make sense, huh? So try to like differentiate, like now I'm in which section of the question, right? So for example, what I see on the screen here, I use rho to represent the r radius from this curve center. So this curve also give you one new center. This curve also one new center. So every curve, different shape of curve will give you different center of the curve, and always pointing inside the curve and not outside. Right, this curve in, so the center is here. This one curve in, center will be inside. Curve in will be inside. Okay. So the rest you read lah. So already explained the direction, normal and tangent direction. They are normal to each other or perpendicular to each other. Okay, important is how you apply the things. Huh? Okay. Now, you know the V, how you draw the V. V is always tangent, right? So it's always tangent. So later we will represent, we'll use one simplified notation, which is S dot. S dot means you take the displacement, differentiate with time, S dot. So V, when you see S dot, it means velocity, means ds dt. So we use S dot here, okay? So when it become collinear, this one v ds, it will become s dot. I'll simplify. I will just simplify, but you can still remain to use s dt if you want, right? And familiar with something, if you see s equal to s bracket t, it means it move in the t function. It means in the t function. So for example, all these things, these two equation is in t function. Right? V equal to something related to time. This one S also related to time, for example. But again, this is a curved motion. So we slowly go into vector, a bit detail on a vector now. So we know that velocity is a vector. Vector have magnitude and direction. So in our equation, we have magnitude. I use yellow color to represent my magnitude V, and my direction is UT. So UT means is in the tangent direction this way. If I write UN means it's going inside. Okay, so now this chapter you will see two numbers or two alphabet for the velocity and acceleration. So we start with the velocity. V equal to small v and U t. So this is UT means in the tangent direction. If I change this one to N means it's pointing inside the curve. Right. Same with the acceleration. So V equal to V UT, magnitude direction. Yellow is magnitude, U is direction. This is velocity. So this is vector. Again, we will start to use chain rules that are already uploaded in the Canvas and ask you to go into Canvas, look at the appendix C. So now we want to use time differentiation to get acceleration. What is the definition of acceleration? dv dt. So when you differentiate this equation, you will get acceleration. Okay, so I write lah. A equal to acceleration equal to v dot. V dot means you time differentiate your velocity. dv dt equal to u dot v ut plus v dot u dot t. This one, chain rules. Do you need me to write this one out? What is chain rules? V equal to V equal to V ut. So when you A equal to dv dt means you time differential of your V. Your V now have two vectors, so you use chain rules. So this is so-called U. This is so-called V. So what you do, okay, chain rules, okay, right here. Okay, chain rule Y equal to UV, let's say. So dy dx, sorry, dy dx. How you do dy dx with the u and v? You write du d sorry, du dx no, not this one. When you do dy dx, what you do? You take the first one, you differentiate the second one, dv dx. Means you remain the first one for the first one, plus you already remain, so the second one you differentiate the second one, v du dx. This is a chain rules. So you don't understand this one, go to appendix C, go and read what is chain rules. There's an example there. So if you apply this principle, you will get this equation, right? So you differentiate this one. So dv dt. So the first one, you remain v. You differentiate the second one, dut dt plus, go to the second one, ut, and differentiate the first one, dv dt. So this one become v, this one u dot t dot. We already agree that when we use dot means you time differentiate with time, plus ut and v dot. That's why what you see on the screen there lah. Okay, this is a chain rules, the chain rules. And the yellow color magnitude, red color their direction. Yeah, yellow color magnitude, red color is direction. We are dealing with vector now. Okay, now go slowly. So what does it mean? What does it mean? What does it mean? So this is a ut. Sorry, let's say you have a u. The change of u, you can break into, you can break this one to ut and un. Means initially you are like that, then you change this one. So you have a d theta here. D theta is a change of this du, this vector. Right. So by completing this vector, okay, if you look at this vector diagram, so you're completing this triangular, vector triangular. So this is a resultant. How you write resultant equation? Resultant equal to start plus n. This is start vector, end vector. So this one equal to this one plus this one. Make sense? This is a rectangular vector triangular. Okay. So again, this one I go very fast. I don't ask you the derivation steps. I ask you more on application. So du lies on this one, lies on the radius. This one du always pointing to the center. The curve always have the same radius at that particular point. So we write du equal 1. Equal 1 at the arc of r. So du dt we will write as 1. So this one we write as magnitude 1. Okay, this one more mathematics. I don't ask you on the derivation. So again, magnitude of du, this one will be 1 d theta. Okay, it will be 1 d theta. This one I go fast. I don't ask you this one. Important is the next slides. Okay. So this one you arrive at one equation, du dt equal to d theta un. This one it takes some time to digest, but again I don't ask you the derivation. This one you read the slides. So when you time differentiation of this one, means you dt here, du you dt, you get this one. You just simplify, become dot. This one you you dt also, means you dt the whole equation, dt here, right? So you get the magnitude. Okay. Then just now we also agree that s equal to r theta. S equal to r theta here. So you replace the r as rho. S equal to rho d theta. Then you do some derivation, and so on. You arrive at one equation. This one you read, all the derivation, I don't go deep there. Okay. This is the important part for tangent, for the curve, that you use tangent and normal direction. First equation to memorize: A equal to AT UT plus AN UN. Okay, so memorize what is AT. AT in tangent direction, you are using V dot. What is V dot? dV dt, which is an acceleration definition. Okay, so what happened to the velocity in tangent when you have a curve? What happened to the velocity? It always follow the tangent direction. Remember, your V always in this direction. Okay, so when you differentiate this one with time, you get acceleration in tangent direction. Yeah. Okay, then AN, memorize, AN equal to V square over rho. This is important. V square over rho, what is this? V is the green color right on the whiteboard here. Tangent velocity divided by rho. Rho is the radius. Okay. Recap. When you're given a curve, I change the shape a little bit. When you're given a curve, straight away, go to the dot. Depend on the direction of the object. So let's say this object move up. So straight away, where is your tangent? Your tangent is this direction. Where is the normal? Follow the curve direction. This is the n. Okay. Now you're sure given a velocity. A velocity value v equal to 10 meter per second. Straight away, use your ruler, follow the tangent direction. Because this is 90 degree. Draw the velocity along the tangent direction. Once you have v, you can convert this diagram into acceleration. Acceleration, you know that you have normal direction and tangent direction. You have tangent direction and normal direction. So you write A T U T plus A N U N. You write this one, you get 1 mark. You write this one, you get 1 mark. Continue. Expand this one. Expand this one. You write A T equal this one. A T equal what? Normal vector, right? Recall what is acceleration definition that you learned since the beginning. A equal to dv dt or v dot. But you can memorize any this form. You write this one, you get another point. What about the normal? You write an equal v square over rho. Where is this v? The green color v, the tangent direction. Okay, you write this one, you get another one without substitution. Yeah, so for the second half of the lesson, this is the important diagram and equation. Okay, again, just to test your understanding. Let's say you have curve like that. You have a point there. Let's say this object moves down here. You move here. It gives you the direction. You move from the top to down. So first step, what you do, you draw axis. Go to the point, draw axis. Use your ruler, draw axis. This is positive, positive. Go this way, positive. Go this way, positive. Because it's going down. So this is what? This is tangent. You write T there. You write N here. Straight away. This is on your free body diagram. You draw this one, you get 1 point. Then another mark is where? If you're given velocity, let's say 5 meters per second, where is V? Follow the tangent. Don't draw this one. Follow the V. Follow the T direction. You can overlap with T. Then write V here. Okay, write V there. Okay. Then the question will still ask you, after you get V, the question will ask you, what is your A? Straight away, write the equation. A equal to AN or UN. You can write the T first or N first, never mind. As long as you are showing that you understand that you can break into normal and tangent direction. Right? So again, what is AT? AT equal V dV dt, and you are differentiate on the tangent direction V. Write this one. What is AN? AN equal to V squared over rho. This is direction. Why link to the rho? Because normal pointing where? Pointing inside the normal. This is your rho. This is your R. So you can't go wrong one. Normal is the radius, so rho inside the equation. Tangent means the velocity that you learned previously, always tangent to the curve. So you won't go wrong one. If you confuse these two, then the rest calculation will be wrong. Yeah, so this equation is important when it comes to curvilinear motion question. Make sense? Make sense, huh? Okay, so this is important. This slide is important. You always come back to this equation. Every time you see curvilinear motion, straight away draw axis, then draw velocity. Then write this equation. Write this equation. Tell yourself what is AT, what is AN. Right, that one. Then substitute value only. This is a substitute. There's nothing, the procedure is fixed already. Okay? Procedure fixed already. Now, the rest is the same. The rest is the same. So, yeah, the rest you read from there. Okay. So I purposely put one equation there where it's very familiar since the beginning. AS equal to VdV. This one is in tangent direction. This equation used when you need to solve anything that relate acceleration and velocity. This one you integrate. Okay, already cover these two equations here. Okay. Next is how to draw your acceleration direction. Just now, this slides here is on the velocity just now. Now, once you have the AN and VN, AT and VN, on your free body diagram, you need to know how to draw your AT and VT. So it won't go wrong again. Once you have your diagram ready, let's say I take this one as a sample. Where is your AN? AN is in N direction. So you go inside your free body diagram. You can overlap. Draw a arrow pointing to the N. This is your AN. Then draw, you have AT, right? Is in tangent direction. So you have AT. These two form what? Form a vector diagram. What you show on the screen there. It's a vector diagram. You know how to find resultant, right? This you have one vector 90 degree. Basically, it's a triangular. Again, it's a trigonometry question. Trigonometry question. You can find the side of the triangular, right? If you have a right angle. Let's say I give you A, B, and C. You have C, you have B value. Can you find A? How to find A? A square equal to B square plus C square. This is trigonometry problems. So to find A, what do you do? A equal square root B square plus C square. You square this one. Sorry, square this one, square this one, square root, you get the magnitude of this one. It's a right angled problems, a triangular problems. Okay. So they explain how to get the magnitude. Magnitude, you take tangent, normal, square it, square root. Because this is a right angled triangular problems. AN, AT square plus AN square. Like what I write on the whiteboard there. B square plus C square square root. You get this answer. Okay. Now again, if I ask you the direction, it's a right angle triangular question, trigonometry. This is the angle. So you should able to apply tangent sine theta with this diagram. Okay. So although the equation looks complex, but it's still applying back to the basic fundamental mathematics. Yeah. So I go a bit fast. So just a summarize of what happened to a particles or acceleration. Let's say you look at the left-hand side. The particle moves from the left to the top of the diagram. So this particle, let's say you move at this point, you should able to understand now when you have a curve, normal always pointing inside the curve, tangent always tangent 90 degree from the center. So you have AT, AN. What is the equation for AT? A equal to dV dt. What is the equation for AN? V square over rho. So by next lecture, when I point to AT, you should able to recall, okay, how to find AT, dV dt. How to find AN, V square over rho, straight away. Okay. Then how to find resultant? This is a right angled triangular. So how to find this resultant? Square this one, square this one, square root, you get the resultant. How to find the angle? Angle, your angle is here. This is a right angle triangular. Angle is here. Use trigonometry. Okay. Same with this one. This is an elaboration for that one. Elaboration, just in case it change, but still the same. You open your finger. Normal always pointing inside the curve. Tangent always follow the motion, but it's tangent 90 degree towards the center. Then find the resultant also same, right? Now another tricky question. Sometimes I give you easy question like this one. What happened when you move in a straight line? It become a tangent question. When you move in a straight line, your acceleration is a tangent component, not normal. Normal only happen when you have a curve. Make sense, huh? So if the question is say that the particle move in a straight line, it's a AT problems, or you link back to the previous early equation. What you learn from here, early equation, go back to here and solve. When it become curve, then only you call back the two equation that we mentioned just now. AT is what? dV dt. AN is V square over rho. That's it. That's the only difference. The tricky part is here. Sometimes I ask you what happened after the roller coaster. I ask you what is acceleration. after the roller coaster come out from the curve. So it come out from a curve. I ask you what is the acceleration. You are using the AT component. Here, you use the AT. You become AT. Okay. Three-dimensional motion, we'll come to this maybe in the later chapter, right? So three-dimensional, don't worry, is use right-hand rules, right? And it's a cross product. Huh? So again, go feedback vector calculation, right? So now, if you're in the three-dimensional like this, let's say this pathway move in the blue line here, and you have three components. One is the plane component. Plane component, you have normal and tangent direction. Plane, this is a plane, right? When you have plane problems, you have normal and tangent direction. And if it's come out from the screen or from the gray color here, it become z-axis. In this case, we use B to represent the z-axis. So we have one more, UB. Okay. Now, in vector problems, you always use right-hand rules, left, right. Okay, right-hand rules. So UB, how you find UB? You follow the curve of your finger, right? So UB is where? Your thumb, point up, right? So how to calculate UB a vector? You follow your finger. You take UT curve into UN. So you use, when you curve, you become cross. Okay, you use right-hand rules for vector. So the question might ask you, what is the magnitude or what is the direction? Always 90 degree of each other. It's always 90 degree. So it asks you what is the magnitude of the third z direction. You use your right-hand rules. You just look at the problems. Pull out your thumb. Look at your finger. And then you take UT cross UN. Okay, cross UN like that. Cross. Okay. Cross. Okay. So how you calculate it? You go back to the appendix also, right? Now, let's say the question asks you what happened to the UN. You change your thumb, become UN. Right-hand rules also. Where's UN? Here. Going there, right? Follow your finger. With what your finger tell you. B cross to N. B cross to T. You cross like that, right? You cross to T. So again, initially your mind should tell you like where is your N? Is inside. Where's your T? And then where's your B? B is 90 degree to the UT and UN. It's 90 degree. Right? It's like you open up your finger like that. Like that. So you put where's your things it's like 90 degree. Okay. So everything is 90 degree, then you use your right hand rules, and then your thumb is your subject, what you want to study. Then your finger curve is like what component to what component. Okay. Vector is a bit tricky because when you cross something, it will give you negative and positive signs. But I don't go deep into this one. Right. All this you read, all this you read. Okay. Procedure, I did explain just now. This is just additional information for you. Okay. So I want to highlight something is that when you have a constant acceleration, you straight away use the 3 Newton equation. And the A here is the AT direction, which means just now there is a roller coaster diagram and there's a straight line. Once it becomes straight line, you can straight away use Newton equation. Okay. So again, just highlight AN equal to V squared over AT equal to dV dt, what you learned previously. Right. This is another one before we end for today. Just now, you learn about this v square over rho, right? Sometimes the question don't give you the rho. Sometimes this one missing. This one. You need to solve with this equation. This equation won't be given in the exam. This equation won't be given in the question. You need to memorize throughout until you take final exam. Rho equal bracket 1 plus dy dx square. Close the bracket. 3 over 2 means exponential 3 square root 2. Then below there is double differentiation of your y direction, y equation. Okay, this one need to memorize. It won't be given in the exam. Again, when you write this general equation, straight away you get 1 mark. For this module, you memorize all the general equation, you get marks. You don't write, don't mark, don't have marks. Although you get the correct answer, you don't get full marks because you don't write the general equation. Okay. All right. So from this equation, basically you are doing differentiation y equal to ax n plus bn bx something. You're solving a differentiation question. On the top, you differentiate 1 time. Below is second 2 times. So when you have curve motion that you need to solve for a and t direction, there are 3 equations, or maybe 2 equations. 3 equations is you write a equal to an un plus at ut, then write what is an, what equation is this one. Rho equal to 1 plus dy dx square bracket 3 over 2. The careless mistakes usually happen here. Careless mistakes, you always miss out this one. 3/2 means you square root 2, you exponential 3. Then this is double differentiation of the equation. Meaning here, because it's curve, you won't get y equal to mx plus c because it's straight line equation. Curve means minimum is quadratic equation. The rest will be polynomial. Polynomial means axn something. So you are solving y equation with differentiation. Yeah. So it's like this module is like a combination of what your foundation tell you. Okay. Okay, we go for this example, then we have a short break. I go this one very fast, if you understand all the fundamental. So let's say there's a skitter move down from the mountain, and he had a speed of 6 meters per second, had a speed and increasing at 6 meters per second square, means acceleration is given. Determine the direction of his velocity and the direction and magnitude of his acceleration at that instant. Ignore the size of the skitter. When you see this kind of question, you'll be given one equation, which is a curve equation or polynomial equation, right? Right. So it's very direct one. Every time you see one question with a curve with the equation, that is normal and tangent equation, normal tangent question. Straight away pull the one that I write on the whiteboard, write all the 3 equations, and you solve accordingly. So you're given initial position 5 meter, 10 meter, and so on. So straight away, you go to the object there, draw the 2 direction, normal tangent, because it's a curve, right? Then the VA is given. Straight away, you should know where to draw VA, right? VA, this is a curve. So So VA is along this one. I just take out this one. So it's along the T, along the T. So there's a theta there, and there's a theta there. So straight away you go to the coordinate system, go to the skitter object, draw normal tangent axis, write the put in the velocity or any information you know, right? Okay. So you just pull out the skitter, draw the path. You're given y equal to something, right? You're given y equal to something. So draw the v on the tangent straight away. Draw v and then write the velocity. Then there's an angle there. Don't worry about the angle. You're given the one equation. You know that at curvilinear motion with the normal and tangent, you need to do differentiation because you want to find a long lengthy equation. So you need to differentiate 2 times the equation. dy dx, you get 1/10x. So I don't go deep into this one. You do one time because you need to use this value for rho, for the rho value. Okay, for here, you need this value for this one. You differentiate one more, you need this one. So differentiate one more time, this value, you get another one. So basically, the angle here, so x 10, so at 10, x equal to 10, your dy dx, you substitute the value here. So dy dx, your x is 10, you know it's 10. So substitute 10, you get 1. So what is dy dx? It's actually tangent theta. Right? dy dx actually is a tangent. Tangent opposite side. So tangent theta 1. On the tangent graph, again, I get familiar with the tangent graph behavior. What value you get 1? Okay, 45. At 45 degree, you get 1. So you know the theta, your velocity. Okay, your velocity is 45 degree from the horizontal, go down. Velocity. Once you have this one, you have the angle already. Now the next slide is to recall what you learned previously. You write this equation, A equal to AT UT plus AN UN. Recall what is AT equal to dV dt, AN equal to V square over rho. Then how to find the magnitude, square root. Okay. So you just write the equation, right? A equal to dV dt UT plus V square over rho UN. Again, go to the diagram, plug inside the arrow, the 2 arrow for acceleration. You can overlap, but remember to write the acceleration. One is velocity, one is acceleration. So AT equal to 2. Why is 2? We tell you already here. AT along the things. So again, I just you have 2 vector here. You can find resultant completing the vector diagram. So I'm not going to repeat how you get the vector diagram. So you just draw a right-angled rectangular. This is a vector, a resultant vector. And I put a new sign for angle, which is gamma, phi, p, right? So you need to find a curve at that particular position. I bracket 10, 5 is because in the question you are given the 10 and 5. You have x and y coordinate. Okay. So I put inside there. Recall the equation. You do time differential. You do dy dx equation. Do second time. Substitute inside here. Press calculator. You get the rho. Okay, you get the rho. Once you get the rho, substitute inside here. You have the v. V you already given. You have the v. You get the an direction. This one You time differentiate of your V, right? Okay, this one. V, this one is 2, magnitude is 2. Yeah. So the rest you look from the slides. You substitute, you'll get the final answer. Find the magnitude, square root square, you get the answer. Okay. Y2, what is V dot? dV dt. Acceleration was given in the question already. Yeah? That's Y2. Huh? Okay. So then you can find the tangent. Okay. You find the tangent of this one, this angle. So I just give you the workout lah. You go and study how to get the 2, how to get 1.2773. Okay, go and figure it out. Okay, then again, once you find the magnitude, remember to tell the examiner where is the direction of that vector. This is magnitude. You need to tell the angle. Your angle, you will get 12.5. After you get this angle, 12.5 is from the horizontal. So you need to do some drawing here to get this angle. Okay. Okay. I give you also the working. You go and figure out how I get this one. If you draw the mathematics line here and there, you will get this 12.5. This for your checking. Okay. Okay, with this, we stop at example 10. See you next week.